So moving on to question 11, if f of x equals 50 times 0.92 to the x plus 75, what value of x solves this equation, f of x equals 90? So because f of x equals 90, we can put a 90 right there. I'm going to rewrite this 50 times 0.92, that's a 9, to the x plus 75 equals 90. So what your job is to get base exponent equals number. So we're going to whittle this away. I'm going to subtract 75. So I have 50 times 0.92 to the x, and then I have 15, divide by 50. So 0.92 to the x, 15 divided by 50 is 0.3, just straight up 0.3. Now I can put this in log form. Log base number equals exponent. You can use this on Delta Math, I believe, or your graphing calculator, alpha window number 2, and you get x equals 14.439, which is option 2. Number 12, it says the expression x to the third to the negative 2 divided by x squared times x to the fifth can be written, it's supposed to be as 1 over x to the k, where k is some integer. So what you're going to do is you're going to simplify that. First thing, I have a power to a power, so I'm going to multiply those. X to the negative 6. Now down here, I am multiplying with common basis, so I'm going to add my exponents. X, oops, not a negative 7. X to the 7. Now we have common basis, so I can subtract them, negative 6 minus 7, and I get x to the negative 13. Now that's not right. We can't have a negative in our exponent, so I'm going to put it in the denominator, x to the positive 13. And they want to know what that little exponent is. It's 13. Speaking of 13, question number 13, which statement about the graph of f of x equals log, that's a little base, 8 of x minus 1 is false. So what I did was I put this in the calculator. I looked at the table, and at 0, I get an error, and 2, 0. 1 was a decimal, so I didn't bother to write that. And then when I graphed, my logarithm graph looks like this, and there was an asymptote here. Okay, so it says the x-intercept is 2, 0. Well, that's true. Okay. The graph has no y-intercept. That is also true. The graph never crosses that asymptote. The graph has a horizontal asymptote. It doesn't. Logarithmic graphs have a vertical, so that's false. The range is the set of all real numbers. That is actually true. You have an arrow going this way and an arrow going that way, and range represents y values. So your answer is right. Now number 14 is similar to number 11. So what I would do is pause this, try this on your own, and then come back and watch the video to see how you did. G of x equals 22, so we're going to put that in here. I have 1/5 to the 2x plus 7 minus 3 equals 22. Before I do anything, I need to move this plus 3 if you want to get base exponent equals number. So I have 1/5 to the 2x plus 7 equals 25. Now you have options. You can put this in logarithmic form, just like we did for number 14, and then solve for x. I actually am going to do that, and then I will cross it off and show you method of common basis. So I'm going to do log base number equals exponent. And I did the common basis, so I have to put this in the calculator now. Let's see. I'm going to pause this because you guys know how. So I went to my graphing calculator and I put in log base 1/5 of 25, and then I got -2. Now 1/5 is the same thing as 0.2, so that's why I put that in. So I have -2 equals 2x minus 7. So I am going to add 2 to both sides. Wait a second. What am I talking about? I'm losing my mind. It's lunchtime. I'm going to add 7 to both sides. That's not right. Sorry, I'm going through this. It would help if I put the right thing down. Okay, now it's going to work. -7, -7. So I have -9 equals 2x divided by 2. So I have -9/2 or -4.5. That's how you would do this, just like the problem above with logarithms. Let's pretend, shall we, that we want to do this with common basis. So I'm going to do this next to it. So I would make 1/5, 5 to the -1, 2x plus 7, and 25 is 5 squared. So those cancel. So I have -2x minus 7 equals 2. I'm going to add 7 to both sides. -2x equals 9, divide by -2, and you end up with the same answer. It's whichever way your mind works best. Sometimes you can't get common basis, so you have to fall back on your logarithmic methods. We're done. And now we just have to do problem numbers, or page number 16.